Good morning.
Good morning.
Good morning. Yes, we are doing chemical reactions and we have done that combination reaction and decomposition reaction. We have completed this both the reactions, combination reaction and decomposition reaction. We have to look at a reversible reaction, which is page number 27. Have a look at the reversible reaction. Wait a minute. Hello. हाँ सर. अरे रुको अभी, अब तो वैसे भी ट्यूसडे को आएगा तो पीरियड तब तक दे होगा तो मैं शायद आऊंगी तो ले जाऊंगी, है ना? ठीक है सर. Yeah, reversible reaction. Most of the reactions that we have considered proceed quite definitely in a certain direction. Generally, chemical reactions reversible reactions. Generally, chemical reactions are in a way, forward direction. They will not come backward to the reactant. But in some cases, the reactant change into product and product again change into reactant. These type of reactions are known as reversible change, reversible reactions. The direction of reversible reaction will indicate by this arrow. Say arrow of reversible reactions. Here, CuSO4 5H2O. It's a pentahydrate copper sulfate. The crystal of copper sulfate is with the 5 molecule of water. On heating, first this water evaporate and change into CuSO4 plus 5H2O. When some drops or some vapor of water is added to the copper sulfate, it will again change into copper sulfate pentahydrate. This type of reaction is known as reversible reaction. This change of hydrated copper sulfate of anhydrous copper sulfate. This is anhydrate because it do not have molecule of water with this crystal, and this is hydrated copper sulfate. Reversible reaction and equation for this reaction is this. To show the reversible reaction, we use this type of arrow to show that it is reversible reactions indication. In steam is passed over the red hot iron. See what is happen on red hot iron. Vapor of water is passed on this. It change into ferric oxide, Fe3O4 and H2. This is the reaction of red hot iron with water vapor. It takes water vapor and change this iron into iron oxide and release hydrogen gas in the atmosphere. When some air of hydrogen is passes on this, it will again change into ferrous and water. This is also known as the reversible reaction. Here is a thermal dissociation. This is the reversible reaction. Now the reaction is thermal dissociation. Thermal. The dissociation means breaking of substance. Dissociation means breaking of substance. Dissociation. Association. It means breaking down of a substance. Here is the example is NH4Cl. Ammonium chloride break down into NH3 and HCl. Ammonia and hydrochloric acid. And these both are gas and pass into the whatever the container it is. The reversible decomposition reaction brought out only by the heat is known as thermal dissociation. In presence of heat, the ammonium chloride break down into ammonia and hydrochloric acid, and this type of reaction, when heat is required for the reaction, this is known as thermal dissociation. Both the gases are, we take some ammonium chloride in test tube and heat it. What happen here? Both the gases are go upward and cool down here. Cool down. On cooling this, ammonia and HCl again react here and form the deposit here at the base of the test tube. And this is reversible. We can again get the ammonium chloride on cooling down of ammonia and HCl. On heating nitrogen tetraoxide is changed into nitrogen dioxide and nitrogen dioxide. This is also dissociation reaction, and it is take place in the presence of heat. We require heat for this reaction. A reddish brown gas is evolved on this reaction. On cooling this nitrogen dioxide again change into nitrogen tetraoxide. This is all about the reversible reaction and thermal dissociation. Dissociation is breaking down of this compound. On cooling, they will go back to the reactant. Reactant. So this type of reactions are known as dissociation, thermal dissociation, reversible reaction. Now the next reaction is displacement. Displace means change of place. Displacement reactions, it means change of the place. Some substance can change their place and displace each other. This type of reaction is known as displacement. Suppose it's a reactant 1 and it's a reactant 2, and they form AC plus B. C replace B and take the place of B, and form new substance, it is AC, and release B as independent. So this type of reaction is known as displacement reaction. Here more reactive element displace the less reactive element. This is more reactive, this displace less reactive element from a substance and take the place of this substance and release less reactive element from the substance. This is known as displacement reactions. Here is an example of copper sulfate, reaction of copper sulfate with zinc. Zinc is more active than copper sulfate. Copper sulfate react with zinc. Now this copper released by the zinc, copper displaced by zinc and change the substance in this way, zinc sulfate and copper. This will settle down at the bottom. The copper sulfate in a beaker and few pieces of zinc and stir with a glass rod. The blue color of solution gradually turn colorless. It's a blue in color. When we first take, the copper sulfate is blue in color. When the reaction take place with zinc, now the new substance is forming and this is colorless. And the solution become colorless and copper, reddish brown copper settle down at the bottom. This is the displacement reaction. Reddish brown particle of copper settle down in the beaker. So we can say that zinc displaced copper from the compound copper sulfate. One another example of magnesium, when magnesium react with sulfuric acid. Again, same reaction will take place. Magnesium sulfate is produced and hydrogen gas is released. This is hydrogen, magnesium displace hydrogen. Magnesium is more active than hydrogen. So this magnesium displace hydrogen and take the place of hydrogen and form new substance, magnesium sulfate, and release hydrogen gas which is evolved in the reactions. Brisk evaporation take place and hydrogen is evolved when burned with pop sound. This hydrogen gas burned with pop sound on bringing burning matchstick near the mouth of the test tube because of this hydrogen gas. One more example is potassium iodide react with chlorine. Potassium iodide react with chlorine and form KCl and release iodine. See, this is colorless. Potassium iodide is colorless, but a yellow gas is passed in the reaction. Pass chlorine gas through a solution of potassium iodide. Take some potassium iodide in solution and pass chlorine gas in this. The colorless solution turn yellow as iodine is formed due to the presence of iodine. Now the colorless solution change into yellow due to the presence of iodine, due to the forming of iodine in this reaction. From above example, it can be noticed that metal zinc is more active than copper. Zinc is more active than copper. magnesium is more active than hydrogen, and chlorine is more active than iodine. So we can say displacement reactions take place when one substance is more reactive and other is less reactive. The more reactive substance element displace the less active element and take the place of less active element. This is known as displacement reactions. Here is a chart is given of activity of element. When we go down in the periodic table, suppose potassium, sodium, calcium, magnesium, aluminium, so many, zinc, Fe, Pb. When we go downwards in the periodic table, the reactivity of a substance is increases. Reactivity increase. These are the positive electropositive element, and here is a electronegative element: fluorine, chlorine, bromine and iodine. Same thing is here. The when we go downwards in the periodic table, the reactivity, here is a change. There is a change in this. The reactivity decreases when we go downwards in the periodic table. The most reactive element is fluorine and least reactive element is iodine. This is the reactivity of a element. Is it clear? Yes. Okay. The next is double decomposition. Double decomposition. Here is a substance, two places are changed. AB is a reactant 1 and CD is a reactant 2. Now this change into AD and BC, CB. Here is new products are formed. This D take place of B and this C take place of A. There is a double displacement. Two places are changed here. This type of reaction is known as double displacement or double decomposition. Two substances are breaking down here and forming two new substances. Two substances are changing their places, so this is also known as double displacement. Double displacement. Two substances, two places are changed of the substance. There are two types of double displacement. One is precipitation, another is neutralization. There are two types of double displacement reaction. One is precipitation and other is neutralization reaction. First we have a look at the precipitation reaction. In these reactions, a chemical reaction in which two compounds in their aqueous state, aqueous state means solution in water, aqueous state react to form an insoluble salt. There is one salt is insoluble in water, insoluble in the substance, and as one of the product is known as precipitation reaction. Have a look at the example of barium chloride and sodium sulfate. So aqueous solution of barium chloride and sodium sulfate. Now they will change into barium sulfate, BaSO4 and NaCl, and this is the we get in the form of precipitation. This is the white color precipitate is formed in the reactions. The chlorine take the place of sulfate and sulfate take the place of chlorine. So this type there is two displacement of the element. This is known as double displacement, and one product is in the form of precipitation, and this is insoluble, which is settled down after some time at the bottom of the test tube. One more example is here. Copper sulfate react with dihydrogen sulfide. Copper sulfate CuSO4, which is aqueous solution of copper sulfate, react with H2S gas. It forms copper sulfide and H2SO4. This sulfide take the place of sulfate. And form new substance, and this is in the form of precipitation. Copper sulfide in the form of precipitation, and which is black in color. The precipitate of copper sulfide is black in color and insoluble in the solution, and settle down at the bottom after some time. Precipitation is the formation of a solid either when two solutions are mixed. When two solutions are mixed, this can be done when a gas is bubbled into a solution. When a gas is bubbled in the solution also, this type of reaction can take place. Here are some experiments to prove this reaction. Double decomposition, silver nitrate react with HCl and change into AgCl and HNO3. This is in a the indication of precipitation is this arrow. Silver nitrate react with hydrochloric acid and form AgCl. This Cl replace nitrate from the silver nitrate and take the place of chlorine. Chlorine is more active than nitrate and displace nitrate from this reaction and aid with the silver and change into new substance silver chloride, which is white in color and it settle down at the bottom. It's a gas in form. Test tube when a dilute sulfuric acid or a solution of sodium chloride. In place of this, we can use sodium chloride also. A white curdy precipitate is formed. White PPT. BaCl2 and H2SO4, same as the sodium sulfate. BaCl2 react with H2SO4, change into BaSO4 plus HCl. This is also precipitation reaction, and the white precipitate of barium sulfate settle down at the bottom. This is precipitate is always insoluble in the solution. Some example of passing gas. Double decomposition reaction may also occur with the evolution of gas. FeS, ferrous sulfide react with sulfuric acid and form FeSO4 and H2S gas. This is the aqueous solution of sulfuric acid, and it is solid in form. Ferrous sulfide is solid in form. Solid. On reacting this form, the ferrous sulfide, the sulfate take place of sulfide, and this Fe ferrous take the place of hydrogen and form the new substance ferrous sulfide, which is aqueous solution and PPT of ferrous sulfate, and this gas evolved up. On adding dilute sulfuric acid or dilute hydrochloric acid to a metal sulfide, we get metal sulfate or metal chloride, and the offensive rotten egg smelling. This gas is having bad smell, like a rotten egg is evolved. The another type of reaction of double displacement is neutralization reaction. Neutralization reaction. Neutralize means the effect of acid and base can be cancelled here. On adding some base and acid, when they react, they form a salt and water, NaCl and H2O. The effect of acid and base cancel out and form a salt, which is neither acidic or nor alkali or base, is nor acidic and neither acidic nor base, and form water. Water is forming to neutralize the acid and effect of acid and base. The reaction between an acid and base that form salt and water only refer to the as a reaction of neutralization. The effect of acid and base neutralize here, cancel here. Ionic reaction. Here is a sodium having +1 ion, oxide having -1 ion. Same here, hydrogen having +1 ion and chlorine having negative ion. Now change this positive OH ion combined with hydrogen positive ion and form H2O, and Na react with chloride and foam NaCl. This is the neutralization. Cancelling the common ion Na plus and Cl minus, the only charge is the combination of H plus and OH ion to form the unionized water. Here is unionized. There is no ion on this water. It's a neutral. So this type of reaction is known as neutralization reaction. Here are some more examples are given here. In neutralization reaction, a soluble base, alkali, and insoluble base react with an acid to form salt and water. The main thing is the product of neutralization reaction is salt and water only. Salt and water only. One reactant is acid and other reactant is base. KOH plus HNO3. Same here, this OH react with H and form H2O and KNO3. Then NaOH plus H2SO4. It is two molecule of sodium hydroxide. Now see, and form two molecule of water and Na2SO4. Na2SO4. It's a salt. Then alkali and acid. Neutralization on insoluble base with an acid. PbO react with HNO3 and form water and PbNO3. PbNO3 whole twice. Valency of plumbum is 2. So it with the nitrate CuO plus H2SO4 react with this and form water and copper sulfate. H2O plus CuSO4. The uses of neutralization reaction. Uses of neutralization reaction. When someone is stung by bee and bee is having acid in its stung. Someone is stung by bee and bee stung has acid. On applying some base on it, we feel relaxed due to the cancellation or neutralization of this acid with this base, and gives pain, which can be relieved by rubbing the spot with the slack lime or a baking soda. Acid present in the stung of a bee, on applying some soda, baking soda or slag lime, they neutralize the effect of acid and neutralize the effect of acid stung by the bee. Another use is when we feel some acidic problem in our stomach, we take ENO. We take ENO because the excess acid is produced in our stomach, and on taking this ENO, this ENO is a base and cancel the effect of excess acid present in the body. This is also a neutralization reaction and feel relief after taking this ENO. It is also known as sodium hydrogen carbonate. And another example is acid that is accidentally spilled on our clothes while doing some activity in laboratory or working at home or any other place. If acid is spilled on our skin, we should immediately wash that area and apply some base on it. In soil, there is somewhat, if the soil is acidic in some places, for the certain cloak, slacked lime is added to neutralize the effect of acid. These are the uses of neutralization reaction. Kindly try to solve this question, or I will give you the answer of this, and I will give you notes for the chapter 1 and chapter 2 within 2-3 days. It is clear? Yes?
Okay.
Okay, try to solve this, or I will give you the answer within 2-3 days, or give you notes also. Okay? Have a nice day.